Telecompany, Douglas Productions and Svetlana Productions, movie H3HA and blah 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 experiment going in Seattle hot weather. Sponsor of program Douglas Konzen, director of stage Svetlana Konzen.
Alrighty then, that was the Fucked Tones and a song called I Was Trying to Tell You Something But You Weren't Listening to Me. That's the song. And what do we got here? So this is quite interesting. I tried to have this phase blank, just nothing at all, not even shorted out, just raw metal. This was primary, this was secondary with a load of a light. And then I tried it, this is primary and this is secondary with a load of a light, and this is blank. There's a video by Tim Tron where that's what he does. He just leaves one completely blank. This works like a shunt bar to collect or guide or direct the back EMF. But I couldn't get that to work. I tried for a while. So I went back to my tried and true primary shorted out coil and secondary. Now my last video, this got really hot, and I also noticed I did it again and all three coils got hot. And I checked for a short or maybe the wires are hitting the core, but there was nothing. So I took this coil out that I wound that I thought would be so great, and I popped in a coil just like this, and it's made from the low voltage side of a microwave oven transformer, very thick wire. I'm hoping this might be a really good battery charger or a looper where I can run like 16 volts or so back into a 15 volts back into an inverter, have the inverter run it, and then do it like that, do something like that. So what I got here is I kept going up in UF value. It's very interesting. I have the load of the light again, and there's only 21 volts coming out of this thing. So there's not enough volts to light up the light, but you can see it glow a little bit. So that just happens to be the load. And what I have here is 132 microfarads worth of caps, of AC oil-filled caps. 132, they're all high voltage, oil-filled. And I started out, I don't know if I'm going to be able to show that to you, screwing things up, but I started out with just a 30 UF, and it wasn't over unity as far as the current in volts out to the load versus the current in volts coming in. And it would drop the input. Every time I added more and more capacitor, the input kept going down and down and down. You know what I'll do is I'll work backwards. I'll show you what it is right now. And then I'll like take off 30. This one's 30 UF. I'll take off 30, then I'll take off 20, then I'll take off something else. And you'll see. Okay, so this is the input here. 10 amps AC, and it's coming straight from the grid. So I'm going to turn it on. It's on. Look at the input. Very low, 0.07 amps times 100 volts. What is that? 120. So it's drawn about 8 watts right now. The transformer's humming, you can feel the vibration. Nothing's getting hot either, unlike my last video. So here's the amperage going to the load. And here's the volts across the load. So it's about 22 watts, something like that. Now watch, okay, this is what I wanted to show. Here's the input. When I take off, let's say I take off this last one here, everything's in parallel. Okay, so now it's like 102. Now you notice the amps has gone down. Voltage has always been staying about the same. The amps output to the load has gone down to 0.78, while the draw has gone up. Now I'm going to take off the other one. So the way this is supposed to work is when you get this thing kind of in resonance, the load and the secondary output, it makes the draw go down. You could say it's power factor correcting, but I don't know if that's the right way to describe it. But so here is now I'm going to take off 20. And you see the draw, not the draw, but the output has gone down into the load. It used to be 0.78, now it's 0.61. And you see we already have 100 milliamps. Coming from the grid. Okay. This might be boring for some, but this is, I think this is fantastic. Okay, so now what do we have? We have a 30 over here. 30 and a 42. So I have 72 UF across. 0.61 output into 21.6. The voltage has gone down a little bit, but I now have 100 milliamps coming in, so that's like 12 watts already, and this isn't even 12 watts or whatever. So here, okay, now I'm going to take off this one. No, let's take off the big one. No, let's take off this one. Be easier to do this one. So there's another parallel cap, not in parallel anymore. Still going. Okay, so Now what do we got? Now we have only 340 milliamps going to the load with a 42 UF in parallel to the light. Here's the glow of the light. There's a little bit more, you know, when I had everything, but I forgot to film that. Okay, but now look, see what the draw is from the grid? 145 milliamps. So, you know what I'll do is I'll hook up this. Here's where I started to notice it, is I hooked a 30 You know how you're not supposed to use both hands when you're working with high voltage? Just one, so things don't go right through your heart. Well, when you got a camera in your right hand, you will have to use only one hand. Okay, there. Now it's gone up to 61. Whoops. Okay, so draw right now is 107. We have 72 UF cap, and there's 0.61, 600 milliamps going into the load. But if I disconnect that 30, now it's not 610 milliamps, it's only 34. It's almost dropped in half, the output, while the draw has gone up. So adding more capacitance on the secondary and the load makes the draw go down. Down, down, down. I could probably go even more with this. So hold on a sec. Wait one moment. Okay, I'm back. So this is the final tally with all these caps in parallel for about 132. So I just want to check what you can declare as the in and out. So the output's about 23 watts, while the input's about 9 watts. 0.078 times 120 is about 9 watts, 9.3 I think. So let's add one more big cap to this monster thing. What do I got here? Here's a 30. Okay, I bet you this will make even more amps output and less draw. I'll bet you. Okay, remember right now it's 0.078 input, and I will add a 30 UF cap. I know everybody's going to say, Cone, you ought to make a cap box. Yeah, whatever. Okay, so do this. I have got zapped a couple times. These don't have a bleed resistor on them, and if you like put your arm on cross here, it'll give you a pretty good shock. Okay, so remember 0.078 input, 1.07 output in amps. And I hook up another 30. Oh yeah, now I have 1.36 output. The voltage will probably be the same, about 22, 23 now. So here's the output into that light. It doesn't have enough voltage to light up, but it's about 6 ohms, I believe. I'm not sure. It's actually a resistive load there. That light, incandescent light. Okay, so 1.35, whatever that is the output. And let's see, remember it was 0.078? Oh, it's gone up now. I've probably gone too far. But still, the ratio is probably better. So now it's 0.091 input, 1.36 times 22. Hold on a sec, we'll do the math. Okay, according to my meters in the calculator, it's about 31 watts out. 31, that's 22.8 times 13.1.35. 1 amp and 350 milliamps. This is the output. And this is the input, and this is about 11 watts. So that's what it is. Maybe right as it is now, I could charge a battery with this. Maybe if I rectify it. Okay, well, there's the big test. And nothing's getting hot. It's running cool. Okay, thanks for watching.